In this video, we're going to discuss dialing in welds. In order to do so, we have to understand what amperage, voltage, and travel speed do for the weld. Typically, these are tied together in a way that makes it very difficult to adjust a weld. If we can separate them out into individual components, it'll help us better determine what needs to be adjusted and when. To start, your amperage will always be tied in with your wire feed speed, so it'll control your heat input and your wire deposition. Your voltage is going to be tied into an arc length, and so it'll always control your spatter and your penetration. Your travel speed is going to determine your bead size and your consistency. If you can break it down to these 6 components, it makes it real easy to dial in a weld and determine what needs to happen. To start off with amperage, typically what you can do is take your material thickness in a decimal, move the decimal 3 places to the right, and you can use that for your amperage. An example would be if I have 1/8 material, that material is 0.125 of an inch. I can move that decimal 3 places to the right and I have 125 amps. Now this is a starting point. This will get me on the dartboard. From here I can make adjustment up or down if I need to. Voltage is going to be viewed as arc length on an OTC machine. Typically your arc length is going to be set at 0, 0 being in the middle of the scale, and this is the quote-unquote ideal condition. Now this 0 value is going to have a voltage adjustment set in the background, but we don't necessarily care what the actual voltage is. Again, we are looking at eliminating the most spatter and getting the best penetration. Typically, the cleanliness of the material and the gas mixture that you're using is going to be the largest determining factors for adjusting this outside of that quote-unquote ideal condition. If your material is dirty, you're going to want typically less arc length. And if your gas mixture, let's say, has a higher CO2 content, you would want a higher arc length. 0 being in the middle, it is a good starting point on any weld. Your travel speed. Typically, if you set it to 20 inches a minute, that's a good starting point. However, you can adjust it up or down accordingly. On average, you might weld between 15 and 25 inches a minute, and that would be based on material thickness, the joint profile, and the welding process. If you're in doubt, you can set it at 20 inches a minute and see what happens with your weld. If you already have an idea of what's going on, you may want to start it a little bit lower or a little bit higher. For example, if my material is 16 gauge, I might start higher on the scale, so maybe 25 inches a minute. If I have an outside corner versus a T-joint, I might start at 25 inches a minute. If I'm running DC short arc versus DC pulse, I might start on the lower end of the travel speed, so 15 inches a minute. From here, I plug in these parameters and I weld a weld and I see what it looks like and I can go from there. Now to troubleshoot these welds. Once you have a bead laid down, you can see what it looks like and you can determine what you might need to do to adjust that weld. If the weld is too large, you can either lower your amperage or you can speed up your travel speed. If you have too much spatter, you can increase your arc length. If you have undercut on the part, you can either lower the arc length, lower the travel speed, or adjust your torch angle. And if your weld is ropey, you can increase your push angle, you can speed up the travel speed, you can increase the voltage a little bit, or you can add a weave. It does take some time to tweak and dial in your weld. It's always best to make small adjustments and one adjustment at a time so you can determine what you are adjusting and what it's doing to the weld.